Okay, let's be honest. Managing a complex data platform like Databricks can sometimes feel less like steering a ship and more like trying to herd cats
Yeah.
blindfolded.
Oh, absolutely. You've got settings, permissions, configurations layered everywhere. Figuring out what's critical, that's tough.
It really can be. For anyone in an admin role, or even if you're just trying to understand how your environment works, knowing what to do and where, that's the challenge.
That's fundamental, yeah.
And that's exactly what we're digging into today. We've got this really practical source, a Databricks admin checklist, part 2.
Right.
Our mission isn't just to read it, though. It's to, cut through the noise, unpack the really critical points, and pull out those key nuggets for you.
We want this to be a shortcut for you, basically.
Yeah.
A way to quickly grasp the core admin tasks in Databricks, understand why they matter, like beyond just the click this button part, and hopefully walk away feeling more informed.
Yeah, more capable. Think of this as exploring the why behind the list, the details that really make a difference for a secure, efficient, well-run platform.
Exactly. So where does the checklist kick things off?
All right, it starts right where you'd expect, the front door. Users and access management. Controlling who gets in, what they can do.
The absolute foundation. I mean, if you don't get identities and permissions right, nothing else really matters security-wise.
Makes sense.
The checklist hits the basics first. Add in users.
Right.
Usually in the admin console, under users, just pop in their email. Simple enough.
But you don't want to manage permissions one user at a time, right? That sounds like a nightmare.
Exactly. That's where groups come in. Assigning users to groups, again, admin console groups, is key for role-based access control. RBAC.
RBAC, right?
So you create logical groups like data scientists, engineers, whatever makes sense for you. And then you grant permissions to the group on things like clusters, jobs, tables.
So manage the group, not the person. Scales way better.
Way better. Much cleaner. Now, what about the folks who need more power? The admins.
The keys to the kingdom.
Pretty much. Assigning admin roles is how you do that. Again, admin console, find the user options, make admin, but, use this one sparingly, very sparingly.
Definitely. And people leave, roles change. Revoking access is just as vital.
Oh, critical. The checklist mentions removing or disabling users right there in the console. But for bigger orgs, disabling via SCM is usually the way to go.
SCM. Okay, let's pause there. For folks maybe less familiar, what is SCM in this context?
Right. So SCM, System for Cross-Domain Identity Management, is a standard protocol. When we talk about SMM for auto-provisioning,
Okay.
it means you link Databricks to your main corporate identity system, like Azure AD or Okta.
Your IDP, identity provider.
Exactly, your IDP.
Yeah.
And then when someone joins the company, leaves, changes teams, whatever happens in the IDP, their Databricks account gets created, updated, or deactivated automatically.
So it automates the whole user life cycle. No more manual adding and removing.
Precisely. Huge efficiency win. And it keeps things consistent. Now, tied into that is SSO via SAML.
Another acronym, SEMIO.
Yeah, Security Assertion Markup Language. Basically, it lets your users log into Databricks using the same username and password they use for everything else at work, their corporate credentials.
One less password. Always good.
Always good. And it leverages your existing security, like MFA. You set this up in the admin console under single sign-on settings, though only account admins see that by swapping some metadata with your IDP.
Okay, so SEM handles who is in Databricks automatically. SAML handles how they log in securely.
You got it. And to make sure everything's above board, you need visibility. Enter audit logs.
Tracking who did what, when.
Everything. Logins, notebook runs, permission changes. It all gets logged. Usually you configure Databricks to send these logs to your cloud storage like S3 or ADLS, or maybe a monitoring tool like Log Analytics or CloudTrail.
Setting that up and actually looking at the logs sounds pretty non-negotiable.
It really is. How else do you answer who deleted that table or investigate a weird login attempt? Audit logs are your evidence trail.
What about programmatic access, like scripts or tools needing to interact with Databricks?
Good question. That's often handled with personal access tokens or PATs. Users generate these tokens and they act like a password for API calls.
Okay.
The checklist points out managing these in the admin console under access tokens. Admins need to keep an eye on these, review them, revoke old ones. Don't let PATs just linger out there indefinitely. Control that API access.
Makes sense. And the last piece here is identity federation, especially with Unity Catalog.
Right. If you have identity federation enabled at the account level, you'd see it in account settings. It links Databricks identities more directly to your cloud provider's identities. This becomes really relevant with Unity Catalog for even finer-grained permissions tied to your cloud setup.
Wow. Okay. So Users, groups, admins, SCM, SMLS, federation, audit logs. That's a lot of entry points. Why is getting a real handle on all of this so critical for you, the listener, whether you're an admin or just working in Databricks?
It's the bedrock, isn't it? It's the foundation of a secure, compliant platform. If you mess this up, you risk breaches, you fail audits, or you just create chaos where people can't get their work done, or maybe worse, they can see way too much.
Yeah.
Understanding this section, it's not just ticking boxes. It's about building trust and control right from the start.
Okay. Front door secured. We know who's coming in. Next logical step, what data can they actually use? Which brings us straight to Unity Catalog and data governance.
Yeah, this is where Databricks really shifted gears on data management. Unity Catalog isn't just like another feature. It's designed to be the central brain for governing data across all your workspaces.
All of them. Centralized.
Exactly. The checklist rightly says you enable it at the account level first. In the account console, Unity Catalog setup.
Then that involves setting up a metastore.
Correct. Think of the metastore as the central catalog of all your data assets, tables, schemas, volumes, permissions, lineage, everything about the data. You create one, link it to your workspaces, and then point it at your cloud storage, like ADLS Gen 2 or S3, where the actual data files live.
So metastore's the what? Storage is the where?
Perfectly put. And once that central catalog exists, you don't want only account admins managing it, right? So you can delegate.
Yeah.
Assigning metastore admins via the admin console lets others manage the top-level structure within UC.
Okay, delegate control. And that structure starts with catalogs.
Yep, catalogs are the top level, often used for big org units or maybe environments like dev, test, prod. You manage them in the Data Explorer, which is now called Catalog Explorer.
Right, Catalog Explorer. And below catalogs, you have schemas or databases.
Exactly. Schemas live inside catalogs. Another layer of organization, maybe by team, project, application, also managed in Catalog Explorer.
Okay, structure makes sense. Now, the really granular stuff controlling access to the actual tables and columns.
This is where Unity Catalog really shines, assigning table and column level permissions. You do this right in the Catalog Explorer. Go to a table, permissions tab, add users or groups, grant specific rights like select, modify, whatever they need.
Down to the column level.
Down to the individual column. You can say, this group can select these 5 columns, but not the sensitive ones. Super powerful.
Wow. And related to that, understanding how data flows, data lineage.
Yeah, UC tracks this automatically. For tables, views, you can go to the Lineage tab in Catalog Explorer and see exactly which notebooks, jobs, or dashboards created or used that data asset, upstream, downstream.
Invaluable for impact analysis or debugging. Like, if I
Right.
change this table, what breaks?
Totally. And taking security even further, UC enables dynamic row and column level security, RLS and CLS.
Dynamic. What does that mean here?
It means the filtering or masking happens at query time, based on who's asking. It's not just static grants. You define policies using SQL functions. So for RLS, you might write a function like where region, Corinthus or region. For CLS, maybe a function that shows only the last 4 digits of a credit card, mask, credit card number. You attach these policies to tables.
And Unity Catalog just applies them.
Automatically.
Yeah.
Whenever anyone queries that table, UC enforces the policy based on their identity or group membership. Same table, different views for different people, without making copies.
Okay, that sounds like a genuine game changer for privacy. Seriously.
It really is. Simplifies things like sales reps only see their region's data, or only HR sees salary columns. Now, what about data that's not in the main storage linked to the metastore?
Ah, right. Data living elsewhere. External locations and storage credentials.
Exactly. Configured in Catalog Explorer, too. An external location is just a path to some other cloud storage bucket or container. You link that path using a storage credential.
And the credential isn't a user's password.
No. It's usually a service principal or a managed identity, like a secure, non-human ID that Databricks uses to talk to that external storage on your behalf. It keeps secrets out of notebooks, centralizes that external access control.
Got it. So Databricks manages the secure connection. Users just get permissions in UC.
It's nicely. And one more big piece. Sharing data. Delta sharing.
Databricks open standard for sharing live data.
That's the one. Built right into Unity Catalog. You create a share, Unity Catalog shares, add tables or views, and grant access to recipients inside or outside your org. They get live, read-only access using standard connectors governed by UC.
Without copying the data all over the place. Nice.
Avoids that whole ETL mess just for sharing. And finally, how do you keep track of all these permissions you're setting?
Right, it sounds complex. Monitoring permissions with system functions.
Yep. UC gives you SQL functions like show grants. Run them in a notebook or the SQL editor. See exactly who has what privilege on any object. Regularly auditing this is key for compliance.
Wow, Unity Catalog is huge. Covers so much. What's the big takeaway? Why is getting this right so transformative for someone managing Databricks?
It's the move away from potentially siloed workspace by workspace governance to a truly unified account-level model.
Single pane of glass.
Exactly. Consistent policies, simplified compliance, easy and secure data sharing. It makes data governance a core platform capability, not an afterthought you bolt on project by project.
Okay, we've nailed down users and data governance. Now let's talk about the engine itself, the compute, cluster policies and compute settings.
Right. This is all about managing the clusters that actually run your code and process data. Super important for cost, performance, and just keeping things under control.
And you find these settings mainly under compute in the workspace.
Mostly, yeah. The main tool here are cluster policies. Think of them as templates with rules.
Rules like?
Like restricting which VM types people can use helps control costs. Setting maximum numbers of worker nodes so clusters don't get out of hand. Enforcing things like auto-termination.
Auto-termination. That seems critical for cost savings, right? Shutting down idle clusters.
Absolutely essential. If a cluster is just sitting there doing nothing for, say, 60 minutes, poof, it shuts down. Saves a ton. Another good practice is using instance pools.
Instance pools. What's the benefit there?
Basically, they're pre-warmed, ready-to-go VMs. When someone starts a cluster using a pool, it boots up much, much faster because Databricks doesn't have to request new VMs from the cloud provider every time. Better user experience.
Faster starts. Okay. And the checklist mentions separating cluster types, job clusters versus all-purpose.
Yeah, that's a really common best practice.
Yeah.
Use job clusters which spin up just for a specific automated job run and then terminate immediately for your production pipelines.
Transient.
Right. And then use all-purpose clusters for interactive work, like analysts using notebooks. It helps isolate workloads, manage resources better, prioritize production.
Makes sense. And there was a great tip in the source about tracking usage with tags.
Oh yeah, using cluster tags is huge. You can add tags like project.bluefin, owner.alice, environment prod when clusters are created.
Either manually or through policies.
Exactly. And the magic is these tags often flow through to your cloud provider's billing data.
Meaning you can actually see costs broken down by project or team in Azure Cost Management or AWS Cost Explorer.
Precisely. You can finally slice and dice that Databricks bill and see who or what is spending the money. Moves you beyond just one big number.
That's powerful. So thinking about all these compute settings policies, auto-termination, pools, job clusters, tags, how does getting this right impact you, the listener, maybe as an admin or a team lead?
Well, it's your main lever for controlling cloud spend on Databricks. I mean, compute is usually the biggest cost driver. Poorly managed clusters can burn through budget like crazy.
Yeah, I bet.
But it's also about performance guiding users to the right resources and preventing resource sprawl. Dozens of forgotten clusters just sitting there. It's about enabling people to do their work effectively, but within sensible, cost-conscious boundaries.
Okay, users check, data check, compute check. But how do you know if it's all actually working right? Monitoring seems key. Audit logs and usage.
This is your eyes and ears on the platform, keeping track of actions, usage, costs, performance trends after setup.
And the checklist brings us back to those audit logs again.
Yep. Step 1 is making sure you've enabled audit logging to your cloud storage. Those JSON files are the raw data. But the real task is analyzing that activity.
Looking for what?
Things like failed logins, weird permission changes, who's running what notebooks, which jobs keep failing, that kind of thing. Security incidents, operational issues.
And tying those logs back to the cost side.
Absolutely. Reviewing billing data from your cloud portal, which hopefully now has those useful cluster tags we just talked about.
Right. See, it all connects.
It does. So you can see spending patterns by team, by project, identify where the money's going, find optimization opportunities, do internal chargebacks if you need to.
What about drilling into performance issues? Like, why is this specific job so slow?
That's where tools like Ganglia or the Spark UI come in.
Yeah.
You can access them right from the cluster details page in Databricks.
And they show you the guts of the cluster.
Pretty much. Ganglia gives you cluster-level metrics over time, CPU, memory, network. The Spark UI dives deep into a specific Spark application stages, tasks, data shuffling, executor logs, essential for diagnosing bottlenecks.
Low-level diagnostics. And that tag tip again, you mentioned pairing tags with cloud cost tools.
Yeah, this is where setting those tags really pays off. You go into Azure Cost Management or AWS Cost Explorer, filter by your project tag or team tag, and boom, instant visualization of Databricks spend for that specific slice. Super useful.
So why is this whole monitoring piece, audit logs, usage, performance so vital for you?
Because visibility is everything, isn't it? It's your security net, your troubleshooting toolkit, your cost optimization guide, your accountability mechanism. You simply can't manage what you can't see.
Okay, shifting gears slightly. The checklist also touches on how admins support the development side of things. Git repos and CI/CD.
Right. This is about enabling developers to work effectively with version control and automating how code and changes get deployed.
The starting point seems to be connecting repositories.
Yeah, Databricks repos lets you integrate directly with Git providers, GitHub, GitLab, Azure DevOps, the usual suspects. Users can clone repos, work on notebooks or files, commit, push, pull, all the standard Git stuff right from the workspace UI.
Okay, so that's for interactive development, version control.
Exactly. Fundamental for team collaboration.
Yeah.
But then there's the automation part, using the Databricks REST API.
So interacting with Databricks programmatically from outside.
Precisely. This is how you build CI/CD pipelines.
Yeah.
You use tools like GitHub Actions, Azure Pipelines, Jenkins, whatever your team uses.
Your CI/CD toolchain.
Right. Those tools pull the latest code from Git and then use the Databricks API or the Databricks CLI, command line interface, to say, update a Databricks job definition, trigger a notebook run, or deploy other resources.
Automating the deployment flow. And infrastructure as code fits in here too. Terraform, maybe.
Yep. Leveraging IAC tools like Terraform or even just the Databricks CLI scripts lets you define your Databricks setup workspaces, clusters, jobs, permissions, even Unity catalog stuff as code. Check that code into Git, version it, deploy it through pipelines, makes everything repeatable, reliable.
Oh, okay. So why should an admin care about Git and CI/CD? Isn't that more for the developers?
Well, yes and no. The admin needs to enable these capabilities securely, right? Configure the integrations, manage service principals for automation maybe. But fundamentally, it defines how changes get made reliably. A good CI/CD setup means fewer manual errors, faster deployments, better collaboration. It impacts the stability and efficiency of the whole platform, crucial for scaling.
Right. Back to the data itself. Inside Unity Catalog, managing the actual data files. The checklist covers Delta table retention and lifecycle.
Yeah, this is about managing the physical storage behind your Delta tables.
Mhm.
Delta Lake keeps old versions of data files, which is great for time travel.
Time travel querying data as it looked in the past.
Exactly. Rollback mistakes, audit changes. Super useful. But keeping all that history forever, that costs money and storage and can eventually slow down queries that need to read the transaction log. So you need to manage it.
And the command for that is VCUM.
That's the main one. VU might will retain 168 hours, something like that. It cleans up data files that are older than the table's retention period and older than the retained duration you specify. You set the table's retention in its properties, visible in Catalog Explorer.
So VSCUM is the garbage collector for old Delta files, based on retention settings.
Pretty much. Common task is scheduling VSCUM to run regularly, often paired with Optimize, which compacts small files into bigger ones that helps read performance a lot.
Optimize for speed, vacuum for space. Got it.
Right, and you might have broader data lifecycle policies like data moves from bronze to silver to gold, maybe retention changes, but VCUM is how you enforce the cleanup part.
Now, there's a really important warning in the source about VCU and streaming tables.
Oh yeah, this is critical. Be really careful running VACUM with a short retention period, say, less than 7 days, like the example on tables that are actively being written to by Stark streaming jobs.
Why? What happens?
Streaming jobs use checkpoints to remember which files they've already processed. If VACUM deletes files that the stream's checkpoint still references, boom, your stream fails. And it might be hard to recover without losing data or reprocessing a lot.
Ouch. Okay, good warning. So why does managing this Delta lifecycle stuff matter for you, the listener?
Several reasons. 1, dot cost. Cloud storage isn't free. 2, part performance. Too many small files or too much history slows things down. 3, dot governance. Your policies might dictate how long you must or must not keep data. And 4, recovery. Understanding time travel retention impacts your ability to roll back if needed. It's basic data hygiene for Delta Lake.
We've covered a ton: users, data, compute, monitoring, dev practices, data files. The checklist wraps up with 2 areas that are maybe less flashy but absolutely essential: support and compliance.
Yeah, the operational backbone, really. Knowing where to go when things go wrong and making sure you're meeting the necessary rules and regs.
So getting help. How does that work?
The checklist points to the admin console, account settings, support settings. That's one route. But importantly, depending on how you got Databricks, like through the Azure or AWS marketplace, your main support channel, especially for urgent stuff like outages, might actually be through your cloud provider's support portal.
Ah, so Azure support or AWS support might be the first call?
Often, yes. Knowing the right path saves time when things are broken. And then there's compliance.
Rules and regulations part.
Right. This involves things like keeping an eye on resource quotas and limits. You don't want production to stop because you hit some invisible cloud limit. It's also about preparing documentation for audits.
Like for SOC2 or high pay.
Exactly. Or GDPR or just internal security reviews. Having your configurations, policies, and those crucial audit logs documented and ready is vital. You don't want to scramble during an audit.
Makes sense. And a final tip on staying informed.
Crucial one. Subscribe to Databricks status alerts and also your cloud provider's regional status notifications. If there's an incident, you want to know ASAP, maybe even before your users do. Lets you be proactive.
So why should you, the listener, focus on support channels and compliance readiness? Seems like background stuff.
Because it ensures the platform stays up and running reliably. It's how you meet legal and industry requirements, which can have serious consequences if you don't. And being proactive about limits and incidents just makes operations smoother, less chaotic. It's about stability and trust.
Okay, what a journey through that checklist. We've hit all the major pillars, and the checklist finishes by pulling it all together with the idea of a daily, weekly admin checklist.
Right. It's not enough to know how to do these things once. You need a regular rhythm, a cadence, to maintain the platform's health and security over time.
Operationalizing all these tasks we've discussed.
Exactly. The source gives examples, right? Like maybe daily, check the jobs UI for failures, glance at compute for weird cluster statuses. Weekly, review user and group access changes in the admin console. Monthly, maybe audit key Unity catalog policies using those show grants functions.
So it's ongoing maintenance, not just set it and forget it.
Definitely not. The environment changes constantly. New users, new data, new workloads. A regular checklist helps you spot problems early. That job that started failing yesterday. That user who got permissions they shouldn't have. That cluster policy causing issues. Catch it before it becomes a big deal.
So how does putting a routine like this in place help you?
It shifts you from being reactive, always fighting fires, to being proactive, a guardian of the platform. It ensures security stays tight, costs are managed, performance is decent. It just builds confidence, confidence that your Databricks environment is solid and trustworthy.
Wow. Yeah, that checklist really does cover the waterfront, from who logs in to how data is governed, computes control, how you monitor it, support developers, manage the data files. It's all there.
It's a really solid framework. I mean, walking through these areas gives you that mental model for what effective Databricks administration actually looks like day to day.
And it's not just a list of separate tasks, is it? You kept pointing out how they connect.
That's the key thing, I think. The checklist gives you the how-to for each bit. But the real skill, the art of administration, maybe, it's understanding how those bits fit together.
How access control impacts data security in Unity catalog.
Right. Or how cluster tags feed into cost monitoring.
How CI/CD relies on secure API access.
Exactly. Seeing it as an interconnected system. The checklist lays out the parts, but the real challenge and opportunity is understanding how they interlock to build that secure, cost-effective, reliable platform that actually meets the business needs.
That interconnectedness, that's where the mastery lies.
It really is.
Yeah.
And thinking about that system, that web of connections, what parts of that stand out most to you as really critical or maybe the trickiest to get right? Is it that identity to data link? Is it the cost control feedback loop? How audit logs tie it all together? It's definitely something worth pondering for your own environment.
A fantastic thought to leave us with. Thanks for joining this deep dive into the nuts and bolts of Databricks admin, guided by that checklist.